In last class, we have discussed about thermal modeling of machine in off-load condition and different classes of motor duty. Today, we will discuss remaining classes of motor duty, and we will find motor rating based on different classes of motor duty. Out of different classes of motor duty, first class is continuous duty. Continuous duty, as the name suggests, machine will be continuously on and will remain in loaded condition. That's why the straight line represents load is always present across the system. Corresponding temperature rise will be there and it will achieve steady state after some time based on the heating time constant of the machine. Different examples of this class are paper mill, compressor, centrifugal pumps, fans, etc. Second class is your short time duty. As the name suggests, short time duty. That means the motor will be in operation or loaded condition for very short duration of time and enough time is given to cool down the machine. Correspondingly, the temperature will increase during the loaded condition and temperature will keep on decreasing when the load is removed till environment temperature is achieved. This kind of operation is found in crane drives, valve drives, etc. Next class is intermittent periodic duty. In this class, intermittent load will be present. That means for some duration of time, load will be there across the machine. Next duration, load is removed as well as machine will be off. That means completely rest condition. So during on-load condition, machine temperature will keep on increasing and during off-load condition, machine temperature will decrease. The examples of this class are pressing machines, cutting, drilling, etc. Intermittent periodic duty with starting. Now in this class, starting is important because at the time of starting, large amount of current is drawn from the source. Because of that, temperature of the machine increases. After that, after starting, machine runs at normal running condition or rated condition you can say. Then machine will be completely switched off or load is removed along with that. Different examples of this class are cutting, drilling, etc. Intermittent periodic duty with starting and breaking. In this class, starting will be there, running, then breaking. Now, in all these three cases, at the time of starting, huge amount of current is drawn from the machine. Then at running condition, rated current is drawn from the machine. Now, during braking condition, based on the type of braking we are going to use, current will be drawn from the system. So, its effect will be reflected in temperature of the machine. So, temperature we have to use to find the rating of the machine. Then after, machine will be completely rest condition. That is, supply is removed, load is removed, nothing is there for the machine. Different examples of these machines are blooming mills, electrical suburban trains, etc. Next class is continuous duty with intermittent periodic loading. Here, machine will be continuously on, but load is not constant. Load is of variable nature. So, because of that one, temperature of the machine will change. If load is large, temperature will be more. If load is reduced, machine will cool down. So based on that one, this class is continuous duty with intermittent periodic loading. The examples are pressing machines, cutting, drilling, etc. Now we have to select a motor for particular application. Here, continuous duty case we are going to consider. In this case, motor is continuously running a load. Current is drawn from the source. Now, motor rating must be more than the current drawn from the source. That means some margin we have to keep and we have to select motor next higher rating motor from the commercially available machines. Next, we have to consider that torque speed characteristics of motor should match with the torque speed characteristics of the load in operating region. Then we have to be cautious in selecting the motor that our motor is able to supply the starting torque or not. Then motor should be able to operate in stable region in case there is any disturbance across the system. Disturbance may be across the source side. We know that supply voltage variation 10% we can allow. In this disturbance, power supply disturbance region, motor should operate satisfactorily in stable region. Determination of motor rating in case of continuous operation, it was comparatively easier But what will happen if load is fluctuating or intermittent load is connected across the machine? Then equivalent method or approximation method is used to find the rating of the machine. That's why here it is equivalent current, torque and power approximation methods. Here what we will do, based on the type of load or the current drawn from the source during that load condition, we will take the average of that value. Now we know that there are basically two types of losses across the system: constant losses and load dependent copper losses. Now constant losses does not depend upon the load, so whatever may be the load, constant loss will be there across the system. But when the load is increased, then copper loss will increase across the system. So based on this assumption, we will find rating of the machine in fluctuating and intermittent load. Here, two types of losses across the system. We know that constant losses and variable losses. Now, the constant losses, it is independent of load. Whatever may be the load, it will remain constant. So, constant losses for any load, it will remain constant and depends upon the supply voltage, and the voltage we are not going to change. So, it will remain constant. Now, copper loss. Copper loss depends upon the load. If load is more current is drawn from the source, I square R loss will be more. So, copper loss will increase. So, it is load dependent. Today we have discussed about some classes of motor duty, then how to find the motor rating in case motor is in continuous duty, then we have started to find the motor rating in case of fluctuating and intermittent load. So I will complete this one in next class. Thank you and be safe.